The Champaign-Urbana Community Wireless Network, CUWiN, is a special project of the Urbana-Champaign Independent Media Center, UCIMC. Started in 2000 by a group of developers wishing to take advantage of underutilized internet links purchased for public use, such as those in municipal offices, schools, and universities. It began a partnership with UCIMC in 2004, gaining its current special project status. CUWiN inherits UCIMC's not-for-profit status and is devoted to building a network architecture to cost-effectively and efficiently create a community wireless network. The project has built a communications network using wireless networking equipment ranging from commodity personal computers to specialized so-called miniaturized, fanless computers with integrated networking. This is essentially the same Wi-Fi equipment used in homes and offices, but CUWiN put it on rooftops to connect neighbors and form a high-speed community network. It is one of many localized community wireless network projects across the world and is developing a platform which can be reused by certain types of these projects, based on the community's geographic structure. Mission. CUWiN's three-part mission is to connect more people to internet and broadband services, develop open-source hardware and software for use by wireless projects worldwide, and build and support community-owned, not-for-profit broadband networks in cities and towns around the globe. Network architecture. The CUWiN platform intends to provide a meshed, ad hoc, non-hierarchical network topology based on commodity infrastructure and technology. Historically, in such ad hoc networks, scaling problems have arisen as the overhead involved in processing the routing information and maintaining a consistent link state among peers grows beyond the ability of the individual nodes in the network to track and forward it. In effect, once a network of this type has reached a certain size, the routing information alone uses all of the available capacity on the network. Routing protocol. Research into routing protocols has uncovered algorithmic approaches to handle and manage this complexity. While starting up, CUWiN relies on Dijkstra's Open Shortest Path First, OSPF, though they are in the process of implementing a much more amenable routing protocol named Hazy-Sighted Link State, HSLS, and then, later, implementing a modification to it named Adaptive Hazy-Sighted Link State, AHSLS. They estimate that the scaling properties of the Hazy-Sighted Link State family of algorithms provide the ability to scale to thousands or tens of thousands of nodes in a densely packed metropolitan network. Routing metric. As with the routing protocol, CUWiN is also experimenting with a new routing metric introduced by the Massachusetts Institute of Technology named Expected Transmission Count, ETX. ETX allows links to be weighted based on the performance of the link experienced over time. The ability to so weight wireless links is needed due to the dynamic nature of physical environments, where a tree in the winter has no leaves. A wireless link passing through it will be strong. In the summer, the leaves will have grown back, causing the link to have a lower capacity. ETX allows a node to dynamically adapt to the quality of each link. And AHSLS allows nodes to scale their knowledge of the network's topography relative to the distance between nodes. Project architecture. The CUWiN project consists mainly of two subgroups. One is directly concerned with the build-out and maintenance of the network in the Champaign-Urbana community, and the other is directly concerned with the development of the platform and all that entails. Core members: Executive Director, Sasha Meinrath; Chief Engineer, David Young; Outreach Coordinator, Ross Musselman; Senior Network Engineer, Daniel Meredith. Network Engineers, Matthew Isaacs, Joshua King. Senior Software Engineers, Bill Kominski, Brian Cribbs, Zach Miller, Paul Smith, Brandon Boasox, Garrett Demore. User Support and VoIP Coordinator, Stefan Alnet. Policy Advisors, Victor Picard, Ben Scott. Project Webmasters, Stephen Mansour. CUWiN Interns, Tom Wiltsius. Development Team, CU-Wireless-Dev at CUWireless. Net. Partners. CUWiN receives a large amount of assistance in software testing from the Center for Neighborhood Technology. They are building a community wireless network in West Chicago, Illinois using the software CUWiN produces. Wireless Africa program of the Miraca Institute managed by the CSIR, the Council for Scientific and Industrial Research. In South Africa, the city of Urbana, IL, UIUC, the University of Illinois, Urbana-Champaign, Tribal Digital Village, Wireless Ghana. Funding history. December 2003. Received a $200,000 grant from the Open Society Institute. July 2004. Received a $50,000 grant from the Threshold Foundation. December 2005. Received $118,000 grant from the Open Society Institute. July 2006. Received a $500,000 grant from the National Science Foundation. CUWiN, the Champaign-Urbana Community Wireless Network. The National Summit for Community Wireless Networks. The International Summit for Community Wireless Networks.